Good morning, everybody. Today is 9th December 2020. The day is Wednesday, and right now I am with the 10 Matric class. My name is Farhan Mazhar, and the subject we are studying is physics. And today's task is simple. We have prepared a kind of assessment which we'll be doing by the discussion. And my students will do this in their copies, and then they will submit in the knowledge platform and also in their Google Classroom. Today's assessment is basically based on chapter number 10, which is the first chapter in 10 Matric Physics book. The name of the chapter is Simple Harmonic Motion and Waves. So let's start. The very first question on your screen: What did Christian Huygens invent? When did the Christian Huygens invent the pendulum clock? It's a fact. You have to remember that date. Do you remember that date?
Sir, I have like 2 days in my mind. Let me just
So
focus
the
for
marking
one more
scheme is
minute.
right now on your screen. So the final answer will be C part 1656. 1656. Okay?
Yes, sir.
Okay. So the next question is, in a vacuum, all electromagnetic waves have the same. In a vacuum, all the electromagnetic
Speed.
waves have the same speed. That's the A part. Let's check with the marking scheme. Yes, it's the A part. Question number 2, the option is A. Next question, MCQ question. The relation between the velocity, frequency, and wavelength of a wave is V is equals to F lambda. V is equals to F lambda.
F lambda is equal to V. B option.
F lambda is, so it looks the B is the right choice.
Yes, sir.
Yes, the B is the right choice. Question number 3, B is the right choice. Water transfers dash. Water transfers energy. Water, with the help of its waves, can transfer energy from point A to point B.
Energy.
So what's the option? A.
Option A.
A option is the right option. So in this chapter-wise assessment, chapter number 10, simple harmonic motion, we have choose 10, 4 MCQs. So we are done with the MCQ. Now in the section B, in the section 2, I mean, we have short questions. Each question is of 2 marks. Okay. So let me increase the size so you can see them clearly. This is section 2. It consists of short questions. So the first question is, define diffraction of waves. Define diffraction of waves. You know, when the waves, they pass through from a barrier or from an obstacle in their path. So at the edges, the wave fronts bend. So that is called diffraction. So for example, this is a barrier in the path. The waves are coming. When they pass through this barrier, through this gap, the wave fronts will bend. They will change their direction. So that is called diffraction. The exact wording is showing on your screen. The bending or spreading of waves around the sharp, waves around the sharp edges or corners of obstacles or slits. Slits means gaps. Is called diffraction of waves. Roshana and Iman, do you understand this definition?
Yes,
the
sir.
bending, I will share you the mark. I will share with you the marking scheme and the key, and then you will write these in your copy, and then you will take the images, and then you will send me the knowledge platform and the Google Classroom both. Okay? So don't write with me right now. Just understand. That's it.
Yes, sir.
Okay. The next question. The next question on your screen. Define mechanical waves and electromagnetic waves. You see, the mechanical waves are those waves which require medium for their propagation. and electromagnetic waves are those waves which do not require medium for their propagation. The answer, which is coming from the knowledge platform, courtesy of the knowledge platform, mechanical waves. Waves which require any medium for their propagation are called mechanical waves. Examples of the mechanical waves are water waves, sound waves, and waves produced on the string and springs. Electromagnetic waves, waves which do not require any medium for their propagation, are called electromagnetic waves. Radio waves, X-rays, heat and light waves are some examples of the electromagnetic waves. Do you understand this?
Yes,
Yes, sir.
Okay. Oh, shabash, shabash. Thank you. So the next question, question number 7 of 2 marks. He says, define restoring force. Define restoring force. You see, when you stretch a spring, for example, if you have a spring and you stretch it, when you apply force and you stretch it in the spring, automatically a force is generated which is opposite to your force, and that force tries to bring the spring back to its original shape. That force is called restoring force. The answer from the knowledge platform is a restoring force pushes or pulls the object performing oscillatory motion towards the mean position. So when an object is vibrating, so the force which always try to bring the object back to its mean position, that force is known as the restoring force. Ji bete, do you understand?
Yes, sir.
Okay, the next one. If the time period of a simple pendulum is 1.99 seconds, find its frequency. You know, the time period and the frequency, they are related with each other with a formula, very famous formula. F is equals to 1 by T. F is equals to 1 by T. F equals to 1 by T. F equals to 1 divided 1.99 equals to. You just have to do this calculation. You will get the answer. Let me show you the marking scheme. So the question number 8, the marking scheme says F is equals to 1 by T because the T is 1.99 seconds. So F is equals to 1 divided by 1.99. And when you do this calculation on your calculator, the final answer will be 0.5025 hertz. Do you understand this? This numerical, very simple and famous numerical.
Yes, sir.
Okay. So let's move to the next one. The next question is, if the length of a simple pendulum is doubled, what will be the change in its time period? If the length of the simple pendulum is doubled, what will be the change in its time period? If you remember the formula for the time period of a simple pendulum, T is equals to 2 pi under root L by G. T is equals to 2 pi under root, and under the under root you will write L by G. So if you double the length, the time period will become under root 2 times the original time period. You see, this we have to do like mathematically, and on your screen right now it is showing. Let me increase the size. Okay. Now it is showing it's a 2-mark question. The time period of the original pendulum, that is 2 pi under root L by G. So if you make the length double, so in place of the L, I will put 2L, and that under root 2L will be taken to the side. So we will have 2 under root 2 multiplied 2 pi under root L by G. So this 2 pi under root L by G is the previous time period. So the new time period will be under root 2 times the previous time period. A little difficult and very important numerical. It's a short question. And it is also very famous. 100% chance that this comes in a paper. You understand?
Yes, sir.
Okay, okay. So we are moving to the next question. The next question is define transverse waves. Also give example. Transverse waves are those waves in which the particles of the medium, they vibrate perpendicular to the direction of the wave. Transverse waves are those waves in which the particles of the medium vibrate perpendicular to the propagation of the wave. Famous examples are the water waves in a ripple tank. Transverse waves are the mechanical waves in which particles of the medium vibrate about their mean position perpendicular to the direction of propagation of the waves. Ripples on the surface of water are an example of transverse wave. You will remember this. Never forget this definition. Bete, do you understand this?
Yes, sir.
Yes, sir.
Okay, so let's move to the next question. Question number 11. Define longitudinal waves. Longitudinal waves are those waves in which the particles of the medium vibrate about their mean position. Their direction of vibration is parallel to the direction of the propagation of the wave. The very good examples are the sound waves. Okay, on your screen, the answer is showing. A longitudinal wave is a wave in which the particle movement is parallel to the direction of the wave propagation. This means that the particles move left and right, which in turn makes the other particles start to oscillate. Okay, is it good?
Yes, sir.
Okay, let's go to the next question. The next question, question number 12, of 2 marks. Define simple harmonic motion and explain motion of mass attached to a spring. Define simple harmonic motion and explain motion of a mass attached to a spring. So, simple harmonic motion occurs when the net force is directly proportional to the displacement from the mean position and is always directed towards the mean position. One of the simplest types of oscillatory motion is that of horizontal mass spring system. If the spring is stretched or compressed through a small displacement x from its mean position, it exerts a force F on the mass. The restoring force exerted by the spring on the mass will pull it towards the mean position O. Due to inertia, the mass does not stop at the mean position O, but continues its motion and reaches the extreme position B. The mass finally comes briefly to rest at the extreme position B. Ultimately, the mass returns to the mean position due to the restoring force. This process is repeated and the mass continues to oscillate back and forth about the mean position O. It's a 2-mark question. Okay?
Yes, sir.
Okay. Find the time period of a simple pendulum 1 meter long where G is equals to 10 meter per second square. Here the unit is wrong. Okay, this should be meter per second square. Okay, so the very simple, the formula for the simple pendulum's time period is T is equals to 2 pi under root L by G. And you just have to put the values and do the calculation. The formula is T is equal to 2 pi L by G. The L value is 1 meter and the G value is 10 meter per second square. So in your calculator, you will write 2 multiply pi multiply under root bracket start 1 divided 10 bracket close equals to. And you will get this answer. You just need to remember the formula and correctly put these values in your calculator and you will be able to find the answer. What do you say?
Yes, sir. It was simple.
Okay. I will share this paper and its marking key with you. And once we are done with this call, because she has to go, and then you all can write these answers in your copies and then take the images and send me in the Google Classroom and in the knowledge platform. I have assigned both these things in the Google Classroom as well as in the knowledge platform. Everybody understands this? What is the basic task?
Yes, sir.
Okay. Okay. So next question. This is the next section, section number 3. This have long questions, and in them every part is of 4 marks. So the question number 14 is on your screen. It says that let me reduce the size. Okay, the time period of a simple pendulum is 2 seconds. What will be its length on the earth? What will be its length on the moon if the gravity on the moon is 2 seconds? Okay, good morning, everybody. My name is Farhan Mazhar, and today is the 9th December 2020, and the top subject we are studying is physics. I'm in the 10 metric class, and the problem we were working on it, and this is the second session with the 10 metric. Due to the internet, our call was dropped, and now we are once again back. And the time period we were working on the section B, the third section of this paper assignment, or you can say it, and we were on question number 14. It's a 4-mark question. The time period of a simple pendulum is 2 seconds. What will be its length on the earth? What will be its length on the moon? If the gravitational field strength of the moon is 1/6 of the gravitational field strength of the earth, where the gravitational field strength of the earth is 10 meter per second square. So here we go. Here is the marking scheme, and this is showing on your screen right now. So the using the equation T is equals to 2 pi under root L by G. That's the formula for the time period of a simple pendulum. Because we want to find the value of the L, so I will take square on both the sides. So it will become 2 square T square equals to 4 pi square, and under root will be gone L by G. So when you want to make L the subject of the formula, or you want to make L alone on one side, so the formula will become L is equals to GT square divided by 4 pi square. Just put the values. On the earth, the G value is 10, the T value is 2, so it's square divided by 4 pi square. Just do this in your calculator, enter these values in your calculator, and you will find the length of the pendulum on the earth, that is 1.02 meter. Then the same length of the pendulum on the moon. So the length of the pendulum, if you want to have the same time period on the moon, and the length of the pendulum you want to find out, so that will be L equals to gt square divided by 4 pi square. The G value of the moon is 10 divided by 6, and that will be 1.667. Multiply 2 square, the time period should be 2, divided by 4 pi square. Enter these values in your calculator, and the final answer will be 0.17 meter. The length of the pendulum on the moon will be 0.17 meter. So I hope that this is clear to you. The next question on your screen, this is a 4-mark question, section 3 of this assessment. What is meant by the ripple tank? Explain water reflection of water waves with the help of a ripple tank. So, ripple tank is a device to produce water waves and to study their characteristics. This apparatus consists of a rectangular tray having glass bottom. Waves can be produced on the surface of water present in the tray by means of a vibrator. An electric bulb is hung above the tray to observe the image of water waves on the paper or screen. The crest and trough of the waves appear as bright and dark lines on the screen. Reflection of water waves can be explained by placing a barrier in the ripple tank. The water waves are reflected from the barrier. If the barrier is placed at an angle to the water front, the reflected waves can be seen to obey the law of reflection. That is, the angle of incidence wave along normal will be equal to the angle of reflected wave. This topic, basically, this is not included in the SMART syllabus. So, because this was in the assessment, so we are doing this. Otherwise, you can skip this. The question number 16, 4 marks question. What is meant by simple harmonic motion? Prove that the motion of a simple pendulum is a simple harmonic motion. 4-mark question. Let's look at the marking scheme. Simple harmonic motion occurs when the net force is directly proportional to the displacement from the mean position and is always directed towards the mean position. The motion of the simple pendulum is also an example of simple harmonic motion. It consists of a small bob of mass m suspended from a light string of length L fixed at its upper end in the equilibrium position O. The net force on the bob is 0 and the bob is stationary. Now, if we bring the bob to the extreme position A, the net force is not 0. The component of the weight mg sine theta is directed towards the mean position and acts as a restoring force. Due to this force, the bob starts moving towards the mean position O. At O, the bob has got the maximum velocity, and due to inertia, it does not stop at O. Rather, it continues to move towards the extreme position B. During its motion towards point B, the velocity of the bob decreases due to restoring force. The velocity of the bob becomes 0 as it reaches the point B. The restoring force mg sine theta will still act towards the mean position O, and due to this force, the bob again starts moving towards the mean position O. In this way, the bob continues its to and fro motion about the mean position O. This diagram is very important. You have to draw this diagram also. Let me show you this diagram. So you see, you have to draw this diagram as well. This is the weight. The weight is acting downward, and this component of the weight is mg cos theta, which is balanced by this tension. But the component of the weight, this component of the weight, which is mg sine theta, this is acting as a restoring force. So remember this diagram also and include this in your answer. And don't make this diagram at the bottom of your answer. You should draw this diagram on the top of your answer. So that's it. So that's it for today. We have done this. We have discussed this assessment, And this assessment was about chapter number 10 of the 10 metric physics. The name of the chapter is simple harmonic motion and the wave motion. And we are practicing, we are doing these question answer sessions to prepare our students for the metric exam. So I hope that this is helpful for you in preparing for your exam. So that's it. And thank you very much, everybody. And my name is Farhan Mazhar, and I was with the 10 metric class. We were working an assignment on the chapter 10 of the physics. So thank you very much and have a